This is Professor Pelton. This is Algebra 2, Chapter 7, Section 5. We're solving equations of rational equations again in this section. In part 2 of the video, the difference is these equations have more than one term on some sides of the equations or both sides of the equations. Therefore, they're not equivalent to cross multiplying, but the same method can still be applied. So we still need an LCD. So lowest common denominator. So I have three denominators. There is an x in common, and then there is a 4 left over. So 4x is the common denominator. Okay. So again, the same strategy still applies. Multiply on both sides. So we have 5 over x plus 7 over 4 equals negative 9 over x. Okay. And this whole side has two terms and the right side has one term. They both get multiplied by 4x because when you solve equations, what you do to one side of the equation, you do to the other. So that gives me 20x over x plus 28x over 4 equals negative 36x over x. You don't necessarily need to distribute through if you can cancel in your head, but I recommend it so that you don't mess up. Okay, so that's going to cancel, leave me with a 20. 28 over 4 is going to leave me with 7x. And the right-hand side is going to cancel actually with negative 36. So I'll subtract 20. So 7x equals negative 56. And we'll divide by 7 and get x equals negative 8. If you plug that in, it works just fine. It gives you the correct answer. Okay, so those are all monomial denominators. Let's try the next one, which has a polynomial binomial denominator. Again, this has multiple terms on both sides, so it's not equivalent to cross multiplying. If you try that for yourself because you believe that works all the time, you'll get them all wrong, unfortunately. So, lowest common denominator. Well, they have nothing in common. This denominator is 1, the other one's x minus 5, the other one's x. So we have 1x, x minus 5 as the common denominator. So 1 over 1 minus 8 over x minus 5 brackets equals 3 over x brackets. Multiply the left side by the common denominator, which is 1x times x minus 5. Multiply the right side by the common denominator, which is 1x, x minus 5. Okay. All right, so we distribute. I get 1x over x minus 5 over 1, which doesn't really matter, the 1, minus 8x, x minus 5 over x minus 5 equals 3x, x minus 5 over x. Okay, so this just leaves me with x times x minus 5. The x minus 5's cancel, leave me with minus 8x. And the x's cancel, leave me with 3 times x minus 5. All right, we're looking good. So we distribute, we get x squared minus 5x minus 8x equals 3x minus 15 when we distribute. So need them all on the left-hand side, so I'm going to minus 3x and add 15. So x squared, let's see, minus 5 minus 3 and minus 8 will give me minus 16 total, plus the 15 constant equals 0. Okay, now we need to do factoring. So we have 1x over 1, which we can ignore, so it's just 1. So 1 times positive 15 is 15, which is 1 times 15, 3 times 5, or negative 1, negative 15, negative 3, negative 5. So those all multiply to positive 15. We need to add up to the middle term, which is negative 16. So the only way that happens is if these are double negative. So that's negative 1 and negative 15. So x minus 1 equals 0, x minus 15 equals 0. So x is 1 or x is 15. And if you plug those both in, they both work in this scenario. Okay, let's try scenario B, or C rather, we just did B. I'm sorry, that was the student problems, or the examples. So pause the video and go to the page 4 and do the student problems for yourself. Okay, student problems. Lowest common denominator. What they have in common is an x. What's left over is a 5, so 5x is the LCD. So we have 15 over x plus 4 over 5 equals 7 over x. So we'll do parentheses here and parentheses there, and times each side times the LCD. So on the top, that's going to give me, let's see, 5 times 15 is 75x. 5 times 4 is going to be 20x. Equals, let's see, 7 times 5 is 35x. Okay, so if I simplify, that's going to give me 75. That's going to give me 4x. And that's going to give me 35. So I think I'm good there so far. So I'll move the 75 over. So I get 4x equals negative 40. And divide by negative 4. So x equals negative 10, which you can plug back in to verify isn't actually a solution. Okay, let's try student problem B. Okay, lowest common denominator. What do they have in common? 2x. Ah, that is a bad 2x. Okay, what's left over? X plus 1. So we have a monomial binomial type mixture here. Okay, so rewrite the problem 3. Wow, I don't know what's happening here. There we go. Okay, we have 3x over x plus 1 minus 5 over 2x. So that's the left side equals the right side, which is 3 over 2x. Okay, multiply the right side by 2x, x plus 1, and multiply the left side by 2x, x plus 1. Okay, so distribute. That's going to give me 6x squared times x plus 1 over x plus 1 minus 10x x plus 1 over 2x equals 6x x plus 1 over 2x. Okay, let me think here. I think we might be good. So we'll cancel and be left with 6x squared. We'll cancel x's here and be left with minus 5 times x plus 1. I think that's good. Cancel x's here and be left with 3 times x plus 1. Okay, so distribute one more time here. So 6x squared minus 5x minus 5 equals 3x plus 3. All right, so we'll rewrite it over here. So 6x squared minus 5x minus 5 equals the 3x plus 3, which will move over. So we can do the factoring. So 6x squared minus 8x minus 8 equals 0. Okay, so we can factor from here. We'll make it a little bit easier, though, by taking out the common factor of 2 first. We're left with 3x squared minus 4x minus 4. That's a little bit easier. Okay, so 2 times, and we'll do our quad form factoring. 3x times 3x gives me 9x squared. So if I divide by 3, that gives me 3x squared. And 3 times negative 4 is negative 12, which is 1 times 12, 2 times 6, 3 times 4. But one of these needs to be negative, correct? So 1 times 12, 2 times 6, 3 times 4. So we need to multiply negative 12, which they all do. We need to add to negative 4. So if I add to negative 4, that's going to be a negative 6 and a positive 2. So I think we're good there. So the second term, 3x minus 6, has a 3 in common. So that leaves me with x minus 2 when I factor out the 3, which cancels with the bottom, which is what we want. Okay, so 2 equals 0, 3x plus 2 equals 0, and x minus 2 equals 0, which means if I add the 2, x is equal to 2, minus the 2, 3x is negative 2, or x is negative 2/3. And of course, the third one is not true. And if you try the 2 answers we did find, both of those are going to work. So we have 2 answers in this situation. So as you can see from the examples so far, you can get 1 or 2 answers. That's certainly possible. And they could be monomials, polynomials, or a mixture of. Okay, let's try problem C. So problem C doesn't even have a fraction for the third one, which is fine. You can make a fraction out of it. Just do 3 over 1. So my LCD, however, is not really apparent here because you have to make sure it's factored completely first. So if I rewrite this, this is 4x plus 1 over x plus 1 equals 12 over x minus 1, x plus 1 equals 3 over 1. Okay. Whoop, that's a bad 3. Because again, they must be factored completely. This, if you think about it, what is that really? That's x squared plus 0x minus 1. Okay, so that the factored form is negative 1 and positive 1 to get that 0. So what do they have in common? They have an x plus 1 in common. What's left over? An x minus 1 and a 1. So that is the LCD. Okay, so we leave a good sized gap here. 4x plus 1 over x plus 1 equals 12 over x minus 1, x plus 1. Oh, lots of plus there. I put equals twice for some reason. Plus 3 over 1, x plus 1, x minus 1. Okay, so in this side, we'll multiply by the x plus 1, x minus 1. Oh, I did parentheses. I should have done brackets. It's a little less sloppy. All right, multiply the left side and multiply the right side. Okay. Looks like we're good there. So as a result, we get 4x plus 1 times x plus 1 times x minus 1 all over x plus 1 equals 12 times x plus 1, x minus 1 over x minus 1, x plus 1. Plus, right? Because this goes to both of them, right? I wrote that wrong. Wow, I can't believe I did that. I added it twice for some reason. I was one step ahead of myself. Okay. Times x plus 1, x minus 1. Okay. So that goes to there, which we did, and that goes to there, which is 3 times x plus 1, x minus 1. Okay. So go to the left-hand side. The x plus 1's cancel. And we're left with 4x plus 1 times x minus 1. Here, everything cancels, just left with a 12. That's it. Plus 3 times, well, x plus 1 times x minus 1 is x squared minus 1 if you want to multiply it out. Back to the original. Or you can spend the time to do it back manually if you really are not paying attention, right? So that'd be 3 times x squared minus 1x plus 1x minus 1, right? All right, so we'll go over to here and distribute. So I get 4x squared minus 4x plus 1x minus 1 when I distribute. All right, equals 12 plus, those will cancel each other, leaving with 3x squared minus 3. All right, let's double check here. Make sure we're good. Yep, I think we're good. All right, so go over to here, and we get 4x squared minus 3x minus 1 equals 12. No, let's see, 12 minus 3 is 9, excuse me. Let's see, 9 plus 3x squared. Okay, so we'll minus the 9 and minus the 3x squared to the side. So we're left with 1x squared minus 3x minus 10 equals 0, right? Okay, so we've combined all our terms and put them onto one side. So now we have a factoring problem. So we'll factor. So 1x, it's divided by 1, but I'm not going to write it. 1 times negative 10 is negative 10. So that's 1 times 10, 2 times 5. But one of these needs to be negative to get negative 10. It needs to add to negative 3. So it looks like positive 2 and negative 5 are the proper factors. So x plus 2 is equal to 0. X minus 5 is equal to 0. So x is equal to negative 2. And x is equal to 5. And both of those, when you plug them back in, are proper solutions. And that is the end of part 2.